Okay, this is our quiz for rates of reaction. It's covering the content, the simple sort of straightforward answers that are needed for grade C's and D's, C's and B's. I'm going to give you a few seconds to answer each question before I give you the answer. I know some of you like to write them down, the rest of you just like to kind of say them in your head. You should probably go through this quiz, I don't know, 3 or 4 times till you really do know all the answers. You can then use them in the longer 6-mark answer questions. Okay, so question number 1. Give an example of a slow reaction. Example of a slow reaction. Okay, the answer is rusting. Question number 2. Give an example of a fast reaction. Okay, this time fast reaction. We're looking for an example of a fast reaction, and the answer is an explosion. Okay, number 3. Why does a chemical reaction stop? So why does a chemical reaction stop? The answer is because the limiting reactant has been used up. So you need to look at the reactants you've got, decide which one is in excess, which one is limiting in terms of its amount, and then that limiting reaction, when it's all gone, the reaction will stop. Okay, question number 4. What are the two common units for rate of reaction? I'm looking for 2 quite different units for rate of reaction. Okay, the answers are grams per second, or you could have grams per minute. And the other one is centimetre cubed per second, or of course you could have centimetre cubed per minute. Question number 5. What is the limiting reactant? A bit similar to one of our previous questions, but a bit more detail needed here. What is the limiting reactant? What is it? What's that definition? The answer is the reactant that is not in excess and is used up at the end of the reaction. Okay, number 6. In terms of particles, what needs to happen for a chemical reaction to take place? What needs to happen for a chemical reaction to take place? The reactant particles need to collide with each other. Okay, for a reaction to happen, those particles have got to actually meet so that the reaction can take place. Question number 7. Name 5 factors that can affect rate of reaction. So 5 factors that can affect the rate of reaction. And the 5 things are temperature, pressure, particle size, concentration, and presence of a catalyst. Okay, number 8. What is a catalyst? Okay, we know it affects rate of reaction, but what is a catalyst? The answer is a substance that changes the rate of reaction but is unchanged at the end of the reaction. So it doesn't actually take part in the reaction completely. It sort of affects the rate, but at the end of the reaction it's still there unchanged. Okay, question number 9. Why does increasing pressure increase rate of reaction? Why does increasing pressure increase rate of reaction? Here's your answer. Because the collision frequency is increased. So those collisions between particles are happening more often. If they're happening more often, there's more chance that the chemical reaction is going to take place, that those collisions will be successful. Okay, question number 10. Why does increasing temperature increase rate of reaction? Why does increasing temperature increase rate of reaction? And your answers are, well, there's 2 reasons. Firstly, the collision frequency will increase. And the second reason is that the energy of each of those collisions has also increased. So there's 2 parts to this answer. Make sure that you don't just give one part. Okay. Next question, question 11. Why does increasing concentration increase rate of reaction? Very similar to one of our previous questions. This one's about concentration though, and the answer is because the collision frequency increases. That is the same answer that was given before. Both pressure and concentration increase the collision frequency. That's why they increase the rate of reaction. Okay, number 12. Which factor should be decreased to increase rate of reaction? So which factor should be decreased to increase our rate of reaction? Okay, the answer is particle size. Okay, because if you decrease the particle size, what you're actually doing is increasing the surface area. Okay, number 13. What is an explosion? Now, we had an example of an explosion in one of the earlier questions. The answer of a fast reaction was our explosion in one of our earlier questions. This one is our definition of explosion. What is an explosion? And the answer is a very fast reaction in which a large volume of gas is released in a short time. So we've got large volume of gas released in a short time. That is our definition of an explosion. Number 14. In terms of particles, why does increasing the concentration increase rate of reaction? Okay, very similar to the answers previously. It increases the collision frequency, so those collisions are happening more often. Number 15, name 3 combustible powders that are dangerous in factories. There's 3 that are actually named as our examples of combustible powders that you need to be familiar with. They are flour, custard powder and sulphur. Okay, number 16. What is this piece of equipment called and what is it used for? You have seen this in the lab being used for our experiments. The answer is it is a gas syringe and it is used to measure the volume of gas that's given off in a reaction. You should be familiar with that one. Number 16. In terms of particles, what does the rate of reaction depend on? Okay. In terms of the particles, what does the rate of reaction depend upon? Okay, your answer is how often a successful collision happens between the reactant particles. So we've actually got to get these particles to collide with each other, and things like increasing pressure and concentration cause them to collide more often. But they've not only got to collide, they've got to have a successful collision so that those particles do actually react with each other and form our new compounds, our products. Okay, number 17. Why does decreasing particle size increase rate of reaction? This is our final question. Why does decreasing the particle size increase rate of reaction? And the answer is that increasing the surface area, because if you decrease the particle size, you increase the surface area, and that increases the collision frequency. Okay, right, that's the end of the quiz.